Hi there, and welcome to Whispers Before Sleep, your quiet corner of the cosmos, where curiosity meets calm and science gently rocks you to sleep. Before we begin our celestial journey tonight, I'd love to know, where in the world are you watching from? And what time is it right now? Let me know in the comments below. It always amazes me how many of us are drifting together from different corners of the globe, connected not just by stardust, but by a shared sense of wonder. So, let's breathe in slowly. And as you exhale, imagine you're floating, not through air, but through the vast, soft silence of space. Tonight, we're not just stargazing, we're traveling back to the very beginning to learn how the universe paints galaxies into existence. Softly, gently, like an artist brushing stars onto a black velvet sky. Let's begin. In the beginning, there was no beginning, at least not in the way we think of one. There was no up or down, no light, no sound, no time, no space. Just a boundless silence that wasn't even empty, it simply wasn't. Try to imagine nothing. Not darkness, not a void, but a true absence. It's almost impossible. And then something stirred, a whisper, not of sound, but of change. Roughly 13.8 billion years ago, everything we know, everything we are, everything we will ever be was compressed into a single point, a moment smaller than an atom, a singularity. But don't imagine it exploding like fireworks. No, that would be far too loud, too sudden, too simple. Instead, imagine a breath, a long, infinite sigh. Not a boom, but a becoming. In this gentle breath, the universe exhaled itself into existence. Space did not expand into anything, it became space. Time didn't begin to tick in a room, it was the ticking. This was the Big Bang. And in this moment, so fast and yet so soft, the cosmos was born. At first, it was unimaginably hot, a blistering sea of energy where nothing could exist for more than the briefest flicker of a moment. Temperatures so intense that even the idea of particles couldn't survive. But the universe was growing, and with growth comes change. As space stretched out, it began to cool, slowly, like tea left under moonlight, its steam fading into the night. Within the first second, something extraordinary happened. The raw energy, that pure, humming vibration of the universe's first breath, condensed into tiny building blocks, quarks, gluons, neutrinos. They were not atoms, not yet, but they were seeds. Imagine a vast, shimmering ocean with ripples of heat and light pulsing through it. Tiny imperfections, tiny shivers would someday shape everything. And then, in just a few minutes, minutes after time itself began, these early particles began to find one another. Quarks joined into protons and neutrons. Protons and neutrons began to bind. And from this great cosmic dance emerged two of the simplest and most important elements in the universe, hydrogen and helium. Hydrogen, one. It was pregnant with possibility. In this silence, the first whispers of structure began to form. Tiny fluctuations in density, no bigger than the width of a human hair, stretched across the entire universe, began to tug gently on the gas around them. These were the fingerprints of the quantum world, frozen into place when the universe was only a fraction of a second old. And now, they were guiding the dance. Gravity, the quiet sculptor of the cosmos, began to pull. Slowly, so slowly. Hydrogen began to gather. Clouds formed, vast and invisible. Over millions of years, those clouds thickened and warmed. And then, quietly,
something astonishing occurred. In the deepest parts of these clouds, where gravity squeezed hardest, temperatures rose again. Atoms slammed into one another with more and more force. And then, almost like a match being struck in the cold, fusion. The very first stars ignited. These weren't stars like the ones we see today. They were giants, behemoths, hundreds of times larger than our sun. Born in darkness, they burned with an intensity that's almost unimaginable. And when their light spilled into the universe for the first time, everything changed. The cosmic dawn had arrived. Photons, light particles, traveled freely for the first time, illuminating the fog. The darkness began to lift. The great veil over the universe fell away, and the cosmos stepped into its own light. These early stars lived fast and died young. They exploded in cataclysmic bursts called supernovae, each one louder and more brilliant than any fire ever seen on Earth. And in their deaths, they gave life. Because in the furnace of their cores, something miraculous happened. Heavier elements were forged. Carbon, oxygen, iron, all born in the hearts of stars. Every atom in your body, every carbon molecule in your cells, every bit of calcium in your bones was once cooked in the core of a dying star. You are, quite literally, made of stardust. And so the whisper continued.
Galaxies began to form.
Gravity pulled stars into spirals, into clusters, into colossal cosmic cities. Some swirled like whirlpools. Some collided, merging in slow-motion ballets that lasted billions of years. Black holes emerged in the centers, silent titans.
Stars are born and stars die. And though we are small and brief and fragile, we are the product of 13.8 billion years of whispers. Each atom of us once danced in the heart of a star. Each breath we take echoes the first breath the universe ever took. We are not separate from the cosmos. We are the cosmos, awake and wondering. Now imagine a quiet place. No wind, no noise, not even darkness in the way we understand it. A place where time itself moves slowly, where things happen not in seconds or years, but across millions upon millions of silent, drifting moments. Out here, there is no sound, but if there were, you might hear a gentle hum, the hum of gravity. Scattered across the early universe were delicate clouds of gas. These were no ordinary clouds. They did not float in blue skies or cast shadows on planets. They were vast, so vast they stretched for light years in every direction. They were made mostly of hydrogen, with a touch of helium, the two simplest elements, born in the furnace of the Big Bang. These clouds were called nebulae, the nurseries of the universe. But in those early eons, they were even more mysterious. They floated like ghostly veils, thin and light, almost invisible in the darkness. Yet inside them, something profound was happening. Left behind by the Big Bang were tiny imperfections, small ripples in the density of matter. These ripples were unimaginably subtle. In one place, there might be one extra particle for every million, and yet that was enough for gravity to notice. Gravity doesn't rush. It doesn't shout. It doesn't demand. It whispers. And so, gravity began to pull. At first, the pull was barely noticeable. Imagine drifting on a still lake and feeling the gentlest tug on the tips of your fingers beneath the water. That's how gravity worked in these early clouds. It gathered particles together, slowly, softly. A lone hydrogen atom, nudged ever so slightly toward another. Over thousands of years, 2 became 3, 3 became 10, 10 became 1,000. The cloud began to feel its own weight, and with weight comes pressure. As more and more gas accumulated, the center of these nebulae grew dense. Particles, once drifting alone through the void, were now colliding, dancing, heating up. The temperature at the core began to rise. Pressure increased, not suddenly, but steadily. Gravity's embrace grew tighter. Millions of years passed like heartbeats, until at last, the pressure became too much to bear. And then, a star was born. It didn't explode into life like a firecracker. It bloomed, quietly, like a candle catching its first flame in the dark. At the core of this dense gas ball, temperatures reached millions of degrees. Hydrogen atoms, under such pressure, began to fuse together. Fusion. This process released energy, balancing the inward pull of gravity with an outward breath of heat. Equilibrium. The same quiet balance that keeps our own sun shining to this day. And once the first star lit up, others followed. Another cloud collapsed, and another star flickered into life. And another. The darkness of the early universe was now sprinkled with points of light. Not blazing, not blinding, but gentle, like fireflies on a summer night, blinking into view one by one. Each star, a small sun. Each sun, a quiet miracle. These stars did not live alone. Bound by the same force that birthed them, they began to group together. Stars, pulled by mutual gravity, started to swirl in slow, beautiful dances. Spirals, clusters, webs of light in the sea of darkness. And these gatherings, these dances, were the first galaxies. Some galaxies formed as gentle spirals, arms curling around like the petals of a sleeping flower. Others clumped together chaotically, dense with stars in all directions. Some were small, mere hundreds of thousands of stars. Others were giants with billions. The universe was no longer dark. From the first quiet breaths of gravity's pull, a new kind of beauty had emerged. A soft glow began to spread across the cosmos. Light that had never existed before was now streaming through space. Photons, once trapped in dense gas, now traveled freely. The fog of the early universe lifted, and everything became just a little more visible. The cosmic dawn had turned into the age of light. Stars, these celestial lanterns, began to shape the fabric of space around them. Their light warmed nearby clouds of gas, ionizing them, energizing them. Their gravity shaped space, pulling in dust and material, creating planets, moons, and the first hints of structure. Stars gave birth to everything. And when some of them died, they died gloriously. Supernovae, massive explosions that scattered heavy elements into space. Carbon, nitrogen, oxygen, iron. The ingredients for life. The very atoms that would someday become us. But none of this could have happened without gravity's patient work. Without that first quiet gathering. Without the invisible arms pulling gas clouds together, holding them gently but firmly until a star could form. Gravity is not loud. It does not flash, it does not scream, but it is always there, guiding particles, bringing order from chaos, whispering stars into existence. And even now, billions of years later, the process continues. In distant galaxies, in quiet corners of space, new stars are still being born. Nebulae still shimmer. Know that somewhere out there a star is being born. Not with a bang, but with a sigh. Not with fire, but with warmth. A reminder that from silence
beauty can bloom, and that the quiet forces, the invisible hands, are often the ones that shape everything. Gravity doesn't ask for attention. It doesn't need applause. But without it, there would be no stars, no galaxies, no Earth, no you. All because the universe listened to a whisper, and the particles obeyed.
Now let's pause here. Take a slow breath. We've wandered through the birth of stars, the gentle pull of gravity, the first soft flickers of light in the cosmic dark. But now, let's step back. Let's look at what all that light has become. Let's imagine the shape of a dream. You've seen the pictures, perhaps in a science book or as a background on your phone, that mesmerizing swirl of starlight, the Milky Way. A delicate spiral, its arms sweeping outward like the slow, graceful turn of a galaxy-sized waltz. Or maybe you've seen Andromeda, the galaxy next door, glowing with quiet brilliance, its core like a lighthouse in the endless sea of stars. But when we look at galaxies from out here, in this space between stars, between thoughts, they feel different. Not just grand, not just distant, but personal. Like memories we never made. Like dreams we've all somehow shared. One of the contract my presh. Imagine this. A swirl of stardust, like cream gently stirred into coffee, or the soft arc of a feather caught in a breeze that never ends. That's a spiral galaxy. Elegant, structured, balanced. Its arms are made of stars, gas, and dust, all slowly rotating around a brilliant center. These spirals often have a bright core, a glowing congregation of older stars, surrounded by graceful arms that sweep outward, like the curves of a nautilus shell. This is the kind of galaxy we live in, the Milky Way. We're somewhere tucked inside one of those arms, spinning slowly at unimaginable speeds, yet feeling no motion at all. From our little spot inside it, we can't see the whole shape, but we can imagine it. We can dream it. Number 1. Then there are the elliptical galaxies. Very different. They don't have arms. They don't have that sweeping spiral elegance. Instead, they are rounded like softly polished stones that have been shaped by eons of cosmic wind and time. Some are almost perfect spheres. Others are stretched like eggs or rugby balls. They're quiet. Their stars are older, dimmer. The gas and dust, the stuff needed for making new stars, is mostly gone. Ellipticals are like the grand elders of the universe, silent, composed, ancient. They often form from cosmic collisions, when two or more galaxies crash together in slow motion, melting into one. There's something beautiful in their simplicity. They're not messy. They've settled into stillness, like an old tree that no longer grows leaves, but still stands with deep roots and long memory, quote unquote. And then there are the wild ones, irregular galaxies. They don't follow rules. They don't fit into shapes. They're chaotic, twisted, free. Some look like they've been torn apart, ripped at the edges by nearby galaxies or intergalactic forces. Others were simply never formed in neat patterns. But even in their disorder, there's a kind of wonder. Their stars burn just as brightly. Their clouds still give birth to suns. Their core may be scattered, but their story continues. Regular galaxies are the wanderers, the outliers, and sometimes the most surprising. Because in chaos, there is always potential. Couple goes. Do you need content 10 time in the American Caldy call Cole Gillian content Cole Gillian? These are the three main types: spirals, ellipticals, irregulars. But like dreams, galaxies don't always stay the same. They change. Over billions of years, spiral galaxies can collide, lose their arms, and become ellipticals. Ellipticals can merge and grow more massive. Irregulars can become more structured or dissolve into nothing. The universe is not static. It evolves. And every galaxy is just one moment, one shape in a long, unfolding story. Well, to our galaxies, those stays prove massive and ellipticals. What's most astonishing is not just their beauty or their size, though they are beautiful and they are unimaginably vast. It's what they contain. Each galaxy, no matter its shape, holds billions, even trillions of stars. Each star is a sun. Each sun could have planets. Each planet could have water or clouds or forests. And each one is a maybe.
What if one of those planets,
What if?
just one, has life? What if someone there looks up at their own sky, wondering what lies beyond? What if they've built telescopes like ours? What if they dream of other galaxies? What if they wonder if anyone else is out there, just like we do? The shapes of galaxies are like fingerprints, each one unique, each one formed by different events, different forces, different accidents of time and gravity. They float across the cosmos like dreams caught in amber. And when we look up, we are looking into the past. Because light takes time to travel, many of the galaxies we see in our telescopes are no longer the same. Some have changed. Some may not exist anymore. But their light still arrives, whispering stories across time, a reminder that everything leaves a trace, even stars, even dreams. So tonight, as you drift off, imagine yourself moving through the universe. Not fast, not with urgency, but slowly, gently.
Floating past galaxies of every shape, spirals spinning like lullabies, ellipticals glowing like ancient lanterns, and irregulars dancing in their own rhythm. Each one carrying billions of suns, billions of chances, billions of dreams. And you, a single heartbeat in the quiet, a thought in the shape of starlight, a whisper in a galaxy of whispers.
Even in this quiet universe, where stars burn in silence and galaxies glide across the vast ocean of night, change is always near. Because even the cosmos is never still. Galaxies move. Not quickly, not frantically. They drift, slowly, silently, carried by invisible tides through a sea of gravity and time. You wouldn't see it in a single lifetime, not even across 1,000. But over billions of years, these gentle giants of light and dust cross paths. And when they do, they collide. But don't think of it like a crash. Not like two cars on a highway, not like destruction. These are not violent explosions. No, this is something else entirely. It's more like a meeting, a conversation, a slow cosmic dance. Two galaxies approach, each one carrying billions of stars, clouds of dust, ripples of dark matter, and perhaps even life. They move toward each other with a grace so vast it escapes our understanding. And then they begin to intertwine. When galaxies collide, their stars, so far apart, rarely hit one another. Imagine this: two great swarms of fireflies drifting through each other in a forest clearing. They pass, they glow, they swirl together, but they don't strike. They dance. It's the gravity that does the work. Like invisible threads pulling and stretching and weaving. The galaxies twist and distort, arms bending, cores stretching, streams of stars flung outward like ribbons in the wind. And from this elegant chaos, something extraordinary happens. Say thing, Kanai-Magai. New stars are born. As the galaxies merge, their clouds of gas and dust, normally scattered and still, are compressed, forced together. And where there's pressure, there's possibility. Like sparks struck from stone, these dense regions ignite, and suddenly nurseries of light blossom in the dark. Stars that never would have existed burst into being because two galaxies crossed path. These are the children of the collision, the bright, hot embers of new beginnings. Kanai-Magai. But not all is changed. Some stars just continue. They glide through the merger untouched, like lone wanderers walking through a crowded festival. Oblivious to the storm around them, they drift on, unaffected, unshaken. It's a reminder that not everything is transformed, that even in moments of great upheaval, some things endure, and that, too, is beautiful.
And this grand cosmic ballet isn't rare. It's not a once-in-a-universe event. In fact, it's happening all the time. Galaxies meet, they merge, they pass through each other, they pull apart and come back together. It's part of the life cycle of the cosmos, a process older than Earth, older than the stars in your sky. And one day, it will happen to us. Yes, the Milky Way will collide. Not with danger, not with doom, but with destiny. Because out there, just over 2.5 million light-years away, another spiral galaxy drifts toward us, Andromeda. It looks small from here, like a smudge in the sky, but it's vast. Roughly the same size as our own galaxy, and it's coming closer every second, slowly, silently, inevitably. In about 4 billion years, Andromeda and the Milky Way will meet. Not tomorrow, not next century, but in the deep future, a time beyond imagining. By then, Earth may be very different, or perhaps long silent. But the dance will happen. The two galaxies will swirl into each other, arms twisting, stars scattering, cores converging. And over time, they will become one. A new galaxy, a new shape, a new story.
Astronomers have already named it. Milkomeda. A blend of what was, a hint of what will be. It won't be a spiral, most likely. The collision may scatter the delicate arms. The final shape might be more like an elliptical, rounded, calm, ancient. And in its core, perhaps, a bright new center, a heart formed from two others. It's poetic, isn't it?
two galaxies, born billions of years apart, in different corners of the universe, falling toward each other across an ocean of space, and finally becoming one. Maybe that's how everything truly begins, not in isolation, but in union, in coming together, in sharing space and story. Perhaps galaxies are like souls, wandering, searching, merging. So tonight, as you close your eyes and your thoughts begin to drift, imagine you are floating, not on water, but on starlight. You pass between galaxies, glowing like dreams in the night, and in the distance, you see two of them, drawing closer, not in haste, but in grace. Their arms reaching, their stars whispering, their gravity singing, a slow, eternal symphony. And you, a quiet observer, watching the birth of something new.
Astronomers have already named it Milkomeda, a blend of what was, a hint of what will be. It won't be a spiral, most likely. The collision may scatter the delicate arms. The final shape might be more like an elliptical, rounded, calm, ancient. And in its core, perhaps, a bright new center, a heart formed from two others. It's poetic, isn't it? Two galaxies, born billions of years apart, in different corners of the universe, falling toward each other across an ocean of space, and finally, becoming one. Maybe that's how everything truly begins, not in isolation, but in union, in coming together, in sharing space and story. Perhaps galaxies are like souls, wandering, searching, merging. So tonight, as you close your eyes and your thoughts begin to drift, imagine you are floating, not on water, but on starlight. You pass between galaxies, glowing like dreams in the night, and in the distance you see two of them, drawing closer, not in haste, but in grace. Their arms reaching, their stars whispering, their gravity singing, a slow, eternal symphony. And you, a quiet observer, watching the birth of something new. Now here's something strange. Galaxies spin, but they spin too fast. If we only counted the matter we can see, the glittering stars, the glowing gas, the faint ribbons of cosmic dust, those galaxies should be falling apart. The stars, especially those far from the galactic centers, should be flung into deep space like petals torn from a flower in a storm. But they're not. Instead, they remain. Bound. Spiraling, yes, but within form, within balance. The galaxies hold together with an elegance that defies what our eyes alone can see. So what's holding them? An invisible hand, a silent force. Something we can't touch or see or hold in our palms, but something powerful. We call it dark matter. But what is dark matter? Well, we're not entirely sure, not yet. It doesn't glow, it doesn't reflect light, it doesn't absorb it either. To our instruments, it's as if dark matter isn't there at all, but its effects are undeniable. Imagine a wind that leaves no sound, no rustle of trees, no flutter of curtains. And yet, you feel it, pushing gently against your skin. You can't see the wind, but you know it's there, by what it moves. Dark matter is like that. It doesn't shine like a star, it doesn't radiate like a quasar, and it doesn't scatter like cosmic dust. But it pulls, it tugs, it shapes. It leaves fingerprints in the curvature of galaxies, in the paths of stars. Even today, every galaxy we know, our own Milky Way included, is cradled within one of these dark matter halos. Imagine a jellyfish pulsing through the ocean, but surrounded by a clear, unseen shell. The jellyfish is what we see. The shell, hidden from sight, defines how the jellyfish swims, where it moves, how it's shaped. That's the relationship between a galaxy and its halo of dark matter. Astronomers first suspected dark matter existed when they studied the rotation of galaxies. The outer edges, far from the gravitational heart, were spinning too fast. Based on what was visible, those stars should have escaped, flung outward like stones from a slingshot. Yet they remained, dancing tightly in their spiral arms. Something unseen was adding gravity. Something hidden was anchoring those stars in place. We've searched for this hidden mass, not just with optical telescopes, but with radio waves, X-rays, gamma rays. We've looked in labs buried deep underground, shielded from cosmic rays. We've launched detectors into space. And still, we haven't seen it, but we've felt it. In the way galaxies cluster together, in the echo of the Big Bang's microwave background, in the lensing of light across the sky, bent not by stars, but by something darker. It's there, everywhere, quiet, enigmatic. It makes up about 85% of the matter in the universe. That means what we see, the stars, planets, nebulae, even ourselves, is just a small sliver, a shimmering frost on top of an ocean of the unseen. Some theories say dark matter could be a new kind of particle, something beyond the standard model of physics, a ghostly cousin of the particles we know. Others think it could be massive objects, primordial black holes, or something stranger still. We don't know, but we're looking, and we're listening.
Galaxies are born. Not with fireworks or sudden bursts, but with patience. With whispers of gravity and soft rivers of gas drawn together by time. They begin as clouds, then stars, then spirals, clusters, arms, and light. Each galaxy, its own island in the dark sea of the universe, cradling billions of stars, nurturing planets, spinning gently to a rhythm older than memory. Galaxies grow. They gather more gas, more stars. They collide with neighbors, absorbing and merging, changing shape, changing soul. Some form elegant spirals, arms outstretched like dancers. Others swell into great elliptical orbs, round and calm. Still others defy symmetry, chaotic and wild, full of stories we may never hear. They grow, they thrive, and then they begin to slow. The life of a galaxy is long, so long it makes the life of a star seem like a blink. But even galaxies are not eternal. Some run out of fuel. The gas they once used to birth new stars, hydrogen, helium, is slowly spent. Star by star, the galaxy dims. No more newborn light, no more stellar cradles, just old stars drifting through a quiet sky. A galaxy without gas is like a garden with no rain. It still holds beauty, stillness, warmth, history, but its growing days are over. Others meet their end more dramatically. Sometimes a larger galaxy passes by. Its gravity, massive and merciless, pulls the smaller one apart. Stars are scattered, gas is stolen, shape is lost. But even in this unraveling, there is a kind of grace. Like petals caught in wind, the remnants drift through space, not destroyed, just transformed. No part of a galaxy is ever truly lost, because what is scattered is shared. Inside these galaxies, dying or torn, the stars continue to burn. For billions of years, even after the last new star is born, the old ones remain, Some swell into red giants, some collapse into white dwarfs, some explode into supernovae, flinging their insides across space. And in their hearts, they've made elements. Carbon, oxygen, iron, gold, all forged in the fires of dying stars. And as these stars fade, they release their treasures. Tiny particles, dust and gas, now enriched with the building blocks of life. They drift through the galaxy like pollen on...
A spiral that once gleamed with blue newborn stars may become a red resting sphere, but its stars will still shine. Its dust will still drift, and somewhere, someday, a star born from that dust may shine on a planet, and on that planet, perhaps something will look up and wonder. The universe is full of stories, but none of them end. They simply blend from one chapter to the next. Galaxies are like great symphonies, starting with quiet instruments, rising in glory, swelling in complexity, and then softening, slowing, until only the gentle, enduring notes remain. A cosmic symphony, not of silence, but of continuity, of eternal rhythm. And as you lay here now, with the hum of stars in your mind and the darkness wrapped around you like a blanket, know this: everything ends, but nothing is lost. The galaxy that dies becomes the soil from which new ones grow. The star that fades becomes the light that gives birth to planets.